Okay, lesson 32, part 3. This is going to be the end of our lecture about batteries, some conceptual information, and then we'll be done. So make sure you know this conceptual information. It always shows up on the ACS exam in some way. So a battery is a galvanic cell or a combined series of galvanic cells that takes chemical energy in the form of redox reactions and converts that into a direct electric current at a constant voltage. So the batteries you buy at the store, the AA, the AAA, they have a number on the side that'll say 1.5 volt. You know about 9-volt batteries. And so all batteries have some sort of constant voltage, and a constant current as a result of these redox equations. So on this image, there is a little bit of a disagreement between the text here in the image. And this image did not come from your book, but the typed information did. And so the incorrect part here is that the manganese oxide is our cathode. Okay, so we have a paper spacer, a paste of zinc chloride and ammonium chloride, a manganese oxide layer, a graphite tube, and a zinc anode. So the cathode is what is being reduced. So remember, keep your constants together. The zinc is being oxidized. So AO, keep your vowels together. And so this is called a primary, helps if I spell it, primary battery. And primary batteries are single-use batteries, meaning once you use them, you throw them away. They are not rechargeable. All the chemical energy is consumed, therefore the redox reaction stops. And so what would happen at when the single-use battery runs out is E cell goes to 0, meaning we're at equilibrium, Q equals K, and the battery is dead. Okay. So the cathode is the manganese oxide, the solid zinc is the anode. The electrolyte here is the ammonium chloride, so this is like our salt bridge. And the carbon rod is what collects the electrons and allows them to leave the battery. So if we think about our galvanic cells before, we had the salt bridge, but then we had this other thing that transported the electrons and completed the circuit. And that's what the cathode rod is. But instead of it completing the circuit, it then exits the battery and powers whatever device you have. So this is a bulb. You can't tell. Bulb on. Okay. These are the half reactions here. This should be up here. I don't know what happened with the copy and the pasting, but that half cell reaction should be above the black line, and it shows you the loss of electrons, the gain of those 2 electrons. So at this point, if you are still listening, I'm going to encourage you. I cannot spell. What is happening? I'm going to encourage you to go on and read your textbook for more information about batteries, because there's always going to be questions on the ACS final that, or on the test that I can't anticipate are coming, very specific questions about primary and secondary batteries, which we're going to talk about. So I want you to go into your book and read about the different kinds that are in the textbook. It should be right at the end of one of the sections about batteries, and just make sure you're familiar with different examples like the alkaline batteries, the zinc batteries like we just talked about, rechargeable batteries, because this new ACS exam that's coming out is going to be brand new since it's being written just for COVID. So I'm not going to get to look at it beforehand and then reteach the material. I'm not going to get it until probably the end of April. And so I want you to read that information. I'm probably going to pull a question or 2 from the textbook specifically because I want to encourage you to read it. And if you read it, I want to reward you for having read it. Okay? And so the other thing I want you to do is, if you're listening, I want you to go ahead and right where I wrote textbook for more information about batteries, I want you to put a smiley face in some sort of colored ink. It doesn't matter, pink, blue, green, yellow, purple, whatever your heart is, but you're going to put a pink or a smiley face next to that so I can see it. If you do it, you get 5 points because you're listening to me talk and you don't just have me on mute and you can hear what I'm saying. And then you will get points. Okay. Lead storage battery. So this is an example of what we call a secondary battery because to some extent it's rechargeable. But we all know that car batteries eventually die. If you've ever had a car battery die, you don't charge it and then use it again. However, if say you left your door open or your lights on or your trunk open and your light stayed on all night, you would come out and your battery would be dead and you could essentially jump it or charge it and it would continue to work for a while, probably for a long time. So we know there's a finite amount of miles in a battery. Okay, so the lead storage battery is an example of a secondary or rechargeable battery. In this case, you have your lead and your lead oxide, which are going to be here. The negative plates in this case are going to be the lead. The positive plates are the lead oxide. And so the lead oxide is going to be your cathode and the lead solid is going to be your anode. Okay. And so another example of a rechargeable battery, now we have the small batteries which are rechargeable and they come in like the alkaline form, but they have to specifically be classified as rechargeable. So you can't take a normal single-use primary battery and recharge it. It has to be a rechargeable battery, but even they have a limited lifetime. There's only so many recharges you get before they then don't hold a charge. Just like your cell phones, your computer laptops, anything that you have that has a battery in it that you can plug in and charge up, eventually the battery stops being able to hold the juice. And so there is a limit on rechargeable battery lifetime. Okay. All right, so that ends all of the batteries that we're going to talk about, and then we'll move on to lesson 33, which is about electrolysis, but that'll be next week.